Good morning, Year 8. Thank you again for engaging with these online lessons. If you can send me, as usual, one of the messages on Show My Homework to show that you're accessing this lesson, and I can mark you off on the register and dish out some reward points. Gave loads out on Friday, which was really pleasing. And then today's activity is going to be mostly self-marking from some worksheets, but there's going to be one short My Maths activity at the end just to consolidate your knowledge of this. And today, as you can see from the title, we're going to be looking at circle work again, but particularly at arcs and sectors. If you just have a scroll down our lesson objectives on the left-hand side, developing students are going to be able to calculate the area and perimeter of semi and quarter circles. That's going to be part of our starter activity, as it's based directly from the end of last lesson. Secure students are going to be able to calculate the area of a sector and the length of an arc. And that's might have had a sneak peek at that if you were looking at the green activities at the end of last lesson as well. And then excelling students are going to be able to use problem solving with arcs and sectors. So we're going to look at a couple of examples of working these problems in reverse. So without further ado, we'll move on to our starter activity. So if you can calculate the area and the circumference or perimeter, if it's not a full circle, of the following shapes, please, and give your answers correct to 3 significant figures. And if you'd like to have a go at those questions, I'm going to pause the video until you're ready to continue, and then I'll run through some answers. Okay, so for our first circle then, we've a radius of 3.5, so our area should have been pi times 3.5 squared. Our diameter therefore would have been 7 centimetres, so pi times diameter for the circumference, pi times 7 to get us the circumference. The second question there, we've got half a circle with a radius of 6, so pi times 6 squared, but halved for our area. And then our diameter here is 12, so pi times 12 for our full circumference. We'd then need to half that for the arc of the half circle, and add back on our 12 centimetre straight line to get our full circumference of this shape. And then the green shape, we've got 3/4 of a circle here, so much the same process. Area, because we've got a radius of 2, area of a full circle would be pi times 2 squared. We'd then need to find 3/4 of that answer for the area, and then for our circumference, the diameter of this circle would be 4, so pi times 4 would give us the circumference of the full circle. We'd need to find 3/4 of that, and then add on 2 and 2 again to include the straight lines for that shape. Okay, we'll move on then to our main part of today's lesson. So we're focusing today on arcs and sectors of a circle. So just to get the terminology out of the way, when we're looking at a full circle, the perimeter of a full circle is its circumference. When we have part of a circle like we have here, then the arc is that section of the circumference which is just related to the circle. So our arc here is going to be the line, I'm just going to sort of outline in red very roughly. That would be our arc. It does not include the straight lines when we're talking about arcs. The sector of a circle is the full section of a circle, and it needs to be split up from the centre to the circumference to make a little wedge, and that would be the sector of a circle. So this is a sector when we're talking about the whole area of the white shape on the board. So if we're looking at how we'd calculate the area of this sector, well, we've got here 1/4 of the whole circle. Therefore, we would use our regular area of a circle formula. Area of a circle equals pi r squared, and then we would find 1/4 of that answer. That's all we need to do for the area of these sectors. If we were after the arc length, that's not the same as asking for the circumference of a circle or the perimeter of a shape. So we'd need to be asking just the length of the curved part of this if you were asked for the arc length. So we'd do pi times diameter, pi times 12 in this case, and then find 1/4 of the answer, and that would be us done. We wouldn't need to add on the straight lines if asked for the arc. If asked for the perimeter though, we would need to add on the 2 straight lines of 6 centimetres to get our final answer. So we're now going to look at some slightly more complicated sectors of circles. So how would we calculate the area of the sector that's shown here? Well, we've definitely got a piece of a full circle, so we need to have a think, what piece have we got? So we have a look here at the angle. So we've got a 60-degree angle here. Now we should all be aware that circles have an angle at the centre of 360 degrees, so we need to work out, well, what fraction of a circle have we got? So there's two ways of doing this. Well, the first way would be to say, well, how many 60s go into 360? And that's going to be 6. Therefore, we could say that we have 1/6 of a circle. Another way of doing this would be to say, well, we've got 60 degrees out of a possible 360, and then we could simplify that fraction down. So you could divide the top and bottom by 10, gives us 6/36, and then divide the top and bottom by 6, and it gives us 1/6 as well. So there's two different ways of looking at it there, both get us down to 1/6, and then we could run the rest of the problem now knowing that we have 1/6 of a circle. So the area of the full circle would be pi times the radius squared, so pi times 8 squared in this case, and then we would find just 1/6 of that answer to get our final area. So the idea here is working out what fraction of a circle we have. So this circle sector here, we've got a 53-degree angle piece. So again here we're going to have to think, well, we know that the circle's out of 360 degrees, so we've got 53 360ths. And actually that isn't going to simplify down any further, so we'd need to leave it like that. So make sure you're writing out full calculations so we can keep track of these fractions until you pop your final answers into calculators today. It may well be the case that in a really high-end question they were asking you to leave your answer in terms of pi, which is another way questions can be asked, in which case you would probably leave your fraction as is until the end of the process. So we've got 53 360ths of the whole circle here. So can we then calculate the area of this sector and the length of its arc? So remember, area is pi times the radius squared, but in this case we didn't have a full circle, we had our 53 360ths of a circle. So that's going to be our starting point here, our regular area of a circle formula, but times by 53 360ths to find that particular fraction of it. So 53 360ths times by pi times by the radius squared. We could have had a line underneath all of this and made it as one big fraction if we wished, which was how we did this last lesson, but both methods are absolutely fine here. And then run that through in your calculator. And we should have 7.40 centimetres squared. So obviously it looks like it's rounded to 2 decimal places or 3 significant figures. Watch out for your rounding parts of your answers, as it is asked for quite often in exams and tests that you round to a particular degree of accuracy, so just watch out for that there. We then want the length of the arc. So we're now looking at something related to the circumference of the circle. Again, circumference is going to be pi times diameter. So we're going to run the same process here. We're going to do 53 360ths multiplied by our normal circumference formula. So 53 360ths times pi times diameter, and that's going to get us our 3.70 centimetres in this case. Again, as per last lesson, watch out for your units. Remember, area has to be in our centimetres squared, and then our perimeter, or in this case, sorry, arc length, is going to be just our regular centimetres. So how about this sector here then? We want the area of it and the length of its arc again. So identify the fraction of the circle we've got. Here we've got 237 degrees out of the 360. So that's the fraction that we can use. 237 360ths. We have a radius here of 6.2 meters. So pi r squared for our area, pi times 6.2 squared is our normal circle area, and times it by 237 360ths. That then gives us an answer of 79.46 meters squared. Let's do the same for the length of its arc. So again, we've got our 237 360ths, but our circumference formula is pi times diameter, so that needs to be pi times, not 6.2 because that's our radius, but pi times 12.4. So watch out for the flip between radii and diameters in some of these questions. and that should give us then 25.65 metres. Again, watching out for our units there. So as a quick rule, if you wanted to get a note down for yourself here, the area of a sector is given as this Greek symbol here, theta. Looks like a sort of big zero with a line through the middle. So the area of a sector is theta angle over 360 times pi times r squared. And the length of the arc is very similar. It's a theta over 360 times pi times diameter. You may well just remember these though as the fraction of a circle you have times by our normal formula, pi r squared for the area, or pi times diameter for the length of the arc. So a little checking point for you to decide on your confidence on this. Can you calculate the area of this sector and the length of its arc, please? So if you'd like to pause the video until you've had a go at this example yourself, and then we can decide on which activity you're going to be having a look at. So we should have here then, for our area, we've got 26 degrees, so 26 360ths times pi times the radius squared gives us 9.59 meters squared for its area. And then for the length of the arc, again, it's going to be 26 360ths times pi times 13, which is going to be our diameter in this case, which is then going to give us 2.95 meters. So have a little look on how confident you feel with this topic. Sort of that halfway point activity wise in the lessons. There's going to be another one of these activities a little bit later on, and then pop yourselves a choice of red, amber or green. Remember, green, all the activities are going to have the same answers ultimately. The green activity one though is if you're very confident because it has zero support for it. The amber activity is if you're just okay with the topic because it has a little bit of help. And then the red activity is if you're not feeling particularly confident with this activity just yet. And then this red activity has the most support for it. But bear in mind, do not do all three. There's only a need to do one of the reds, or one of the reds, or the amber, or the green in this case. So if you'd like to have a go at the corresponding activity that should be attached to show my homework, and then we are going to move on as soon as people unpause the video. So answers as follows. If you could self-mark your questions, please. And then, of course, get in touch with me at red@theroyal.school if there's any of those you're unsure of and don't know how to get the answers. And if you've self-marked, we'll move on to the next part of the lesson. So we now need to look at some problem solving involving these arcs and sectors, and this is going to be, to start off with, working in reverse. So we have here the length of the arc on this sector is 2.54. That's something we were looking in the previous questions. We were calculating the arc length. But calculate the angle at the centre, so we don't have the angle. So we're going to start off, in most problems, it's probably best to just write out what you do know. And we can write out the full process, but we've just got our angle missing in this case. So we saw before that we were using the symbol theta for these missing angles. It is quite often used instead of a regular sort of X or Y letter. Those usually are reserved for side lengths in sort of circle problems. So you quite often see these Greek symbols popping in. So we use theta as our angle here. Now, we knew before that whatever angle theta was, we then have theta over 360 is the fraction of the circle we have. So we can actually write out our full process for getting the arc of this sector just with theta in place of the missing angle. So arc length is theta over 360 times by pi times by diameter. We've got our radius of the circle here is 3.2, so our diameter is 6.4. So let's write out the full process. So we're going to have theta over 360 times by pi times by 6.4, and we know that the arc length is 2.54, so we can actually pop that in as well. So in most maths problem solving, we've got a formula here that we've got one missing value. Unfortunately, in this case, the missing value isn't the subject of the formula, so we just need to do a little bit of rearrangement in order to get theta to be the subject and therefore solve what it is. So how do we get theta on its own? Let's start to reverse the process of the sum that's happening on the right hand side of the equals here. So we've got a times by 6.4 at the end here, so let's reverse that first off. So let's do 2.54 and divide both sides by 6.4. Is going to give us 0.396. You see the three dots here. We don't want to round this number just yet. Save any rounding until the end of the process, because there's going to be some long decimal numbers going involved in this process. We don't want to round too early and make our answer inaccurate. We've then got a multiplied by pi on this right hand side of the equation. So let's get rid of that and divide both sides by pi. And then our missing number, or angle in this case theta, is being divided by 360. So let's reverse that by timesing both sides of our equation by 360. And now we can round our answer to our three significant figures or one decimal place, depending on the accuracy given in the question. And we can get our theta here then as 45.5 degrees. And we've worked the problem in reverse. So there's our problem solving questions. So another one here then, if you're feeling confident, you might want to pause the video and have a go at this. If not, you can just continue to listen through and I'll run through the process with you for this one. So we've got an area of a sector here given as 78.6 millimeters squared. Calculate the angle at the centre. So again, we're missing our angle, which I'm going to list as theta here. So let's write out the full process again. We know that the area of a sector is given as a theta over 360 times by pi times by the radius squared. Our area in this case is given to us 78.6 millimeters squared. Our radius is given to us as 7. Pi we know is 3.14, but it's best to leave the pi symbol in there because we know that's much more accurate than any decimal number, because the decimal number has to be rounded. And theta is what we're after, so that's going to be unknown until the end of the process. So put all the numbers that we can into our formula and then reverse everything out so we can get theta on its own. So at the end of the sum here, we've got a times by 7 squared, 7 squared being 49, so let's divide both sides of our equation by 49. We've got our multiplied by pi at the end of the sum here, so let's divide both sides by pi to reverse that part. And then we've got theta is being divided by 360. So let's multiply both sides of our equation by 360 to get theta on its own. And we have 183.8 degrees. Now, do watch out for these questions. They are usually, roughly speaking, correct. We can see that this part of a circle definitely looks like quite a bit bigger than 180 degrees. Any questions like this won't be drawn to scale, so that you couldn't just get a protractor out and measure the angle and have to sort of skip the whole process that they're asking for here. So they should roughly be looking correctly. If your sector of a circle looks like it should be made with an acute angle, just check that your answer should be acute. And here we've definitely got something bigger than 180 degrees. That's what to watch out for. But it doesn't have to be the case. There can be some odd-looking questions. Just follow the process, and if it says it is not drawn to scale, then you can kind of ignore the diagram once you've read off your numbers from it. So have a think about how confident you feel with our problem solving and reversing the process here. And again, you're going to choose whether to do the red, amber or green for the second activity. And green is our no support, amber is our little bit of support, and red is some heavily supported activity, depending on your confidence with this, but all are the same answers. So if you'd like to have a go at the second activity here, and then we can self-mark in just a moment when you unpause the video. Hey, there is an extension activity then if you were getting through those quite quickly. And again, you might just need to pause that because we're going to run on to the answers in just a second. So give this one a go if you completed the other activities very quickly. Again, problem solving here because we now have a contextual issue going on with this problem. So answers as follows, if you can self-mark please. And again, get in touch with me at red@theroyal.school if you need a hand in getting any of those answers. So thanks again for engaging with these online lessons. I've had loads of lovely work being issued to me over previous weeks, so I hope that's going to continue. Now, there is one short activity on arcs and sectors set on MyMaths just to consolidate your knowledge, and we can then record your scores for this. If you can get that one completed as well, that would be absolutely fantastic. You might consider that to be this week's homework. And then again, if you're issuing or submitting work to me, then please do so via Show My Homework. And then if you can save emails, please, just for those people that need help, that'll keep things very easy to be organised. I do know there's some exceptions where people can't send their work in via Show My Homework, and I've had emails off those people, so that's absolutely fine. But where we can, if we can stick to that, it'd be great. And again, if you haven't already sent me a message to say that you're engaging with the lesson, then please do so I can mark you on my register and then issue you some reward points. Thank you very much, and I'll speak to you soon.